I'm Saneem. I did MSc here for 3-4 years back. Yeah, so I work for IBM Research, and I've been looking at a lot of problems, including the last talk, which was ML for creativity, machine learning for creativity. I'm a part of program committee of one of these workshops in KDD. KDD is supposed to be a conference in Canada. I'm a program committee member for a workshop which we just conducted. It will be happening this August, called Machine Learning for Creativity. And yeah, so probably I'll start from the top. Okay. So recommender system. How many of you have not heard of recommender systems? Oh man, nice, cool. So okay, so recommender system. Okay. Before going to the top, so I have taken too many images from Google that if I start citing every one of them, I'll have to have double the set of these slides. And I took a lot of content from this mmds.org, which is a course by Stanford University. Okay, yeah. So recommendations we get every day, right? So we get recommendations every day from our colleagues, from our friends, parents, and then we take some of them. We don't take most of them. That's why we are this way, right? We're not doing well in the life. So that's probably because we are not taking those recommendations. Now the question is, can we make a computer system recommend us things which we might like, right? So you see this every day in your life. So one very basic example is Amazon recommends me buying earphone. Okay, so so similar thing, like all of these companies also do. Like, so we have Amazon again here, and then YouTube recommends you YouTube videos, and then eBay does the same job as Amazon. Netflix has a lot of movies, and they also recommend you movies which one to watch. And Facebook kind of recommends you people. Oh, it's a little weird, like, oh, okay. Do you think this guy looks cute? Probably you should send him a friend request. Okay, or girl, guy, to you. So yeah, so the thing is, like, we have this computer system which can even recommend you people, and Twitter also does almost the same thing. It says, like, why don't you follow Donald Trump, because he's really funny, one of the funniest person in the world, right? So but Google, okay, can you tell me where Google recommend you something? Ads, yeah, ads, like so that's mostly like what you query, and according to the query it recommends you some ads, but some other part of Google. Which one? Yeah, search recommendations. Yeah, so but the difference between search recommendations and probably the other things are that search recommendations are not directed at you. Okay, it doesn't look at what you are, how you are, or what have you been doing in your life to recommend. Okay, so one place where it works perfect is this Google News. Okay, not many people use it, but in Google News they have something called as For You recommendation, and yeah, and this is mine. So I like football apparently. So that's why. So Google recommends that apparently Messi is gonna stay in Barcelona. So happy news for me. So that's how. So Google News also recommends you which news you want to read. And we want to ask, like, why is this a problem? Why is a recommendation a problem which we need, and how do we solve it? So let me give you a reason why recommender systems are needed. So one is, we have Homer Simpson and he wants to buy something, and there are too many things in the item set that like it's hard to search. So what you do, like, you go to a bookshop and then you keep searching for the books. That you can do if the bookshop is small, but if you have a bookshop of size of Walmart or really huge ones, then it's painful to go to all of these sections and then check for what you need. So we figured out that you can't just search item. It's better that the items, who is having this or who is selling that, let them recommend to you, right? So that happened, and that was not the case some decades back, because we were not spoiled for choices. Like a couple of decades back, we have like scarcity. Okay, we didn't have many things. We didn't have like we probably had like 2-3 games for a computer, but now there are like thousands and thousands of games. Or everything you take, there are more choices today, right? So the reason we have a recommender system is because we have too many things to choose from, and then someone needs to recommend to us. So here you can see like shelf space is a scarce commodity. That means that if there is a shop, they have like, I don't know, 10 shelves. They'll only keep the things which are being sold. But my interest is not the things which is on the shop. I want more. So what probably the shopkeeper will do is he'll keep the things which are most popular, right? So because they have to sell it, there is a real estate cost to it. So they'll keep the one which is most popular, but probably I'm not interested in them. The same with TV networks, same with movie theaters. But because we have websites nowadays, we have huge option of taking like what to buy and what not to buy, right? And this comes from something called as long tail phenomenon. Okay, what that means is that if we want to rank all the products out there on and with x-axis and y-axis is popularity, then we'll get a graph very similar to this. It's called long tail graph. So we have some products which are like very popular, and then we have like this graph coming down. So there are like too many products which are like very less popular, but some people might like things on this side, and most of the people would like things from this side. Okay, so if you want to have a retail shop, what you would do is you will take the most popular ones, and these ones you can't keep because you don't have a shelf space in your shop. So the idea is, can recommender systems figure out which ones from this one you would like, because there's too many of them, and then it will recommend to you, and then you will probably buy it and like it. Okay, so one success story on how recommender system helped a book to be famous is this one. It's called this Touching the Void. It's a mountaineering book published in 1988. It's about this person who goes to one of these Peruvian mountains, and then he has this close to death trouble in the mountaineering, and then he wrote about it in a book. Right? So this book was a pretty good book. It got good reviews back in 1988, but it didn't become a sensation because not many people saw it. Right? But later, like almost a decade later, there is this another book called Into Thin Air. It's a similar story about a person who got into trouble when he was climbing Mount Everest, right? And this was in 1999. The book was published in 1999, and then this book also got good reviews, but it also became a sensation because probably Mount Everest names and everything. So a lot of people bought this, and then what happened is Amazon figured out that we should recommend people this book because they are very similar. They are mountaineering. They're like people getting in trouble and this saving themselves. So what they did is they actually recommended people to buy this, Touching the Void. And it turns out that after this recommendation was put, this book became a bestseller after 10 years. So it was not a bestseller in 1988, but it became a bestseller in 1999 or early 2000s. So this is what a recommendation system can change. So there are things which are real of good quality, but just that people don't see it. Okay. So now the question is, what all should we do to make these recommender systems? Oh yeah. So okay. Let me just get on to types of recommendation. Just 1 second. Okay. Yeah. This is better. Okay, so before going to how we are going to do, let me talk about types of recommendation. So the idea is one way to recommend is there is a editorial person who is like a shopkeeper, probably a person who is an expert in the area. He goes and figures out the best items in the shop and tells that this is the editorial selected or curated list, and you would probably like this. So that is the one option, editorial and hand curated list of favorites. And it also could be list of essential items. For example, if you go to grocery, these are the things people generally buy and you need this to live. So they are like essential items. So that is one way of recommendation. The other one is simple aggregate. What that means is I try to take the most popular items people buy and make a list of it and then recommend to others. So if I go to YouTube and if I select for the most popular video, it would be Gangnam Style. By this Korean artist, right? So this is a list of the most prominent 6 videos in YouTube. So this is one way to recommend. What you have to do is like anyone comes to YouTube, just throw them the most popular videos. But for me personally, I don't like any of them. Okay, I probably like Messi videos again. See, I'm a Messi fan. So what happens is we want something which is very personal to me, looking at my way of watching videos and people who are similar to me, what they do, and so that like you have to use a user tailored recommended systems, and that's what we'll be talking about today. So these systems are used in Amazon, Netflix, Google, and probably a lot of other companies. So why should you learn about this thing is, okay, this is not a great point, but why should you learn about this thing is, you learn about it, you become an expert, you get a job there. As simple as that, right? So to be honest, I have used a couple of recommender system algorithms in my work in IBM research. So you can also get into IBM research. So let me go to the formal modeling, what this problem is. So I'm going to throw a couple of math equations through the talk. I know that this is the last talk of today. I shouldn't have put a lot of equations, but bear with me. So there is set of customers X and there is set of items S. Now we have something called as utility function. Utility function basically says that how much would X like the item S, right? How much would a person like the item S? And then you have a function called X which maps from X cross S, which is a pair of a customer and item to a real number R, and we call that R as rating. So in IMDb rating, people go and rate a movie, right? So similar to that. So ratings could be like a number. It could be a binary, which says that I like it or not. It could also be a number like stars, 1 star, 2 star, 5 star. It could also be a fraction, right? So now I can also represent this utility as a matrix. So we have like 4 people, which is Alice, Babu, Carol, and Devi, the Indian version of the ABCD guys. And then we have like the movies, Avatar, Lord of the Rings, Matrix, and Bahubali. Okay. So these are the values which these people give as a rating out of 1. Okay. Now what we want to do is, given this information, we want to know if Alice would like Lord of the Rings. Okay. And we also want to know if Alice would like Bahubali or not. Or what about all other combinations which we don't have? The question is, can we get this? And if we have an information about, for example, Babu has never rated Avatar, and we have a score of say 0.8 here. What I would do is I would go and tell Babu like, you have to watch Avatar, and that's a good recommendation. But what if Babu has a very low score for Matrix? It's like say 0.1. Then I don't have to recommend him because probably he wouldn't like the movie. So that's how the recommender system works. Yeah. So before going to the next ones, if anyone has, yeah, you have it. Yeah, exactly. Yeah. So I'll talk about that. It's a really good point. What he said was like, what if people don't give ratings to the movies? Like most of the people, they don't give ratings to the movie. We don't spend our time in IMDb. So okay, so I'll talk about that. So let me talk about the key problems in this setup. So one is that gathering non-ratings of metrics. So what we have here in the question marks is the unknown ones, which we want to find. That's what the algorithms would do. But the thing is, how to know the non-ratings of the matrix, how to collect the data in the utility matrix. That's the first question what he asked. Excellent question. And the other one is how to extrapolate the unknown rating. So how do we find the unknown ratings according to this data? Third one is, how do we know that the unknown ratings we predicted, is it any good or not? Okay, I can predict rubbish numbers, but I need someone to tell me if I did good or not. Okay, so these are the 3 problems. We'll take one problem at a time. So first one is gathering ratings. Ask people to rate items, beg people to rate items. Yeah, that's what people do. I mean, there is this website called Amazon Mechanical Turk, where people are paid to do stuff like this, right? But it doesn't work always. So it doesn't work well in practice because people can't be bothered. We can't just tell that you can only watch the next video if you rate the last video. That doesn't work, right? So another way is that you take something called as implicit feedback. So this is explicit rating. This is something called as implicit rating. What it means is, if I watch a video, then by default, I can guess that I like the video if I watch till the end. In the case of YouTube, if I watch only the first 5 seconds, probably I didn't like it. If I watch the 10 seconds, probably I liked it. But whatever, you can use all these heuristics and take that as implicit feedback. It may not work in all the cases, but in the case of videos, yes, it would. And you can also look at the comments, and if they are using a lot of swear words, probably they didn't like the video at all. Okay, so you can use this something called as implicit rating, and the places where we won't have ratings is something called low ratings. Okay, so people are not gonna watch a YouTube video if they don't like it. So that is the same as people who miss that video. So there is this is a serious issue in recommender systems. So we can't be sure that the people, they didn't use a product, is it because they didn't like it, or that product didn't occur to them. Okay, so this is a serious issue in recommender system, and there are like a lot of models, a lot of mathematical tools which can kind of work around it. Not 100% of course, but some percent. Okay, so that is gathering ratings, and the other one is extrapolating utilities. How can we do that? So the key problem is that most of the people have not rated most of the items. So that means U is sparse. The matrix I showed, most of them will have like empty elements. We don't know the ratings, right? And then there's a problem with cold start, which means that if I have a new item, I don't know how people would like it. A new video comes up in YouTube video, YouTube, I don't know who would like it and who wouldn't. And the same with a new user, right? So this is one of the key problem in extrapolating utilities. And I'm going to talk about 3 approaches to this extrapolating utilities, which is, one is called as content-based method, collaborative, and latent factor based. These both are like latent factor based is kind of a subset of collaborative, and content based is entirely different. So before I go to the next slide, if anyone has any questions, any comments to make. Yeah, okay. Yeah, what was the first one again? Yeah. Okay, so okay, let me put it this way. So there are a lot of algorithms people use for a lot of techniques, and it can be put into some classes. Probably it's not entirely into content based or collaborative, but whatever you are saying, what I'm saying is like can fall into one of these, or both, some fraction of here. Hybrid method is kind of content based and collaborative, a merge of them, and SVMs I think should come under content based according to the formulation. So every year there'll be 100 of papers on recommender system coming up. Yeah, we can keep track of it. This like recommender system is one of the most famous problems in machine learning because it generates a lot of money. To be like straightforward, it generates a lot of money because Amazon kind of claims that they increase the revenue by at least 20% by using recommender systems. So if they don't use it, the revenue goes less by 20%. So there's like a lot of interest by people in this community, and there's a lot of techniques people use for their particular problems in general. So yeah, good point there. So I'll be talking about content-based and collaborative-based, and latent factor will be one subset which we'll go into detail. Yeah. So any other question, please feel free to stop me in between. Okay. So yeah. So I'll go to the next slide, which is there is this thing which happened in sometime in 2009. It's called the Netflix Prize. It is one of this key competition which kind of molded the whole of recommender system problem because it kind of put a lot of prize money, and then a lot of people are solving the same problem. So we have something. Netflix had a lot of videos and movies, and 100 million ratings were there, and there are like 480,000 users, 17,000 movies. So we have this many ratings, and we want to recommend which for each user which movie you would like, right? So 100 million ratings for training, and then 2.8 million for testing. So I hope you know what is training and testing. Someone might have taken a machine learning talk before. So you are supposed to learn or use some technique to understand what people like, and then you have to check on some other data, seeing that your predictions are right or wrong. So that is test data. And evaluation criteria is that if you give a rating 5 and the actual rating was 4, the criteria basically says that the square error should be minimum. So if there are two systems which are going to create those recommendation values, we'll compare them by checking this error. Whoever gives better will win this competition. Okay, and there are like 270 plus teams and 1 million prize. And yeah, and so I took this to show you that how to solve the third problem. The question was how to evaluate if a system is working good or not, and this is kind of the answer. Okay, so before I can explain that in a better way. So what we have in Netflix is a utility matrix of this kind. 17,000 movies for 480,000 users. We have all these scores, how they like the movies, and we have too much area of like too much of unknown values, right? The idea is that we take some part of this matrix, say we leave out a rectangle from here, a smaller matrix from here, use the other one, understand how people and movies, like people and the connection to movies work, and then predict for this set, right? And this is exactly what Netflix challenge was. And again, the error is the same, which means that if this is 2, and I'm saying that, okay, I don't know what the value is here, and then I predict something like 3, the error will be 3 minus 1 square, it's like 1. And you have to average out for the whole missing area. Yeah, so, and this actually made a lot of people interested in this recommender system problem, and many papers or many research which you read about recommender system will have used Netflix sometime, or this Netflix data. It's a very publicly available data, and it's a data of I don't know 5 years, 2005 to 2000 to 2005, 6 years, and people use this data and tell that I have a new algorithm. Or for example, if you want to come up with a new algorithm to recommend people on how or predict how the ratings will work, you take this data, show that your algorithm works better than others, and that will be like clear-cut winner, right? So that's what people do nowadays. Yeah, so I'll probably get into detail of these things. Any questions? Yeah, fine. So how many of you have heard of these ones, content-based? So I clearly know that you have used, or you have also heard of it. 3. So like, how did you do some projects on it, or you have elective in college on recommender system or on in general machine learning? Data analytics. Okay. And how would you know these topics? Okay. Okay. I'm user of getting my project as well as something that matches with my skills. Okay. And like vice versa. Okay, cool. So you learn from project. What about you? Online course, Coursera, I suppose. Okay. Okay, cool. Yeah, so probably for others it will be more interesting, I suppose. So content-based recommender systems. The basic idea of content-based recommender system is that utilize information about the items. Okay, so the way it works is there is a customer X, and there are previous items. So the idea is you will recommend the things to customer X according to the items he liked before. Okay, so in the case of movie recommendations, if I like movies based on some actors, genres, and everything, and there's a new movie coming up which kind of matches the genre and actor, then that will be recommended to me. So the idea is you look at the details of the items, see like what are the ingredients of that item, and then it matches with whatever I liked before, and then recommend it to me. So that's the basic concept of content based. So so let me just explain with diagrams how actually content based work. So again, Homer Simpson likes Martian, and we figured out that Martian is, you know, some item profiles. You have to get some value, some understanding about this movie. So it has Matt Damon, and it has fantasy. It's a fantasy. It's a sci-fi, and who is Ridley Scott? Ridley Scott. Yeah, he's the director of the movie. Okay, so we have this information about the movie. Now what do we do? Now I'll go search through the whole. So this is just one movie he liked. We'll have plenty of movies he liked. So and we'll have similar information set for each of the movies. What I do is I go to the whole like database of movies, search for these combinations, see which one fits the most, and then recommend to him. So we figured out that Matt Damon is there in this movie called Invictus, and fantasy, sci-fi, Interstellar is one, and also so is Avatar. And what I would do is I'll just recommend to him. Okay, all other movies probably I'll skip. Probably the movies which has drama, which is war-based movies, I'll skip, and I would give more on the actor and the other director matching. Now, how do we do it in a systematic manner? So first, for each item, create an item profile. That's what we did. So we got Martian. We found who is the actor, who is the director, what genre it is. So that's how we create an item profile. And so one way is like item profile is kind of, you can create a vector out of it, because if you want to like do some cool math with it, you need to have it in some vector format, some mathematical notations, right? So one way it is make it a vector format. So in movies, it could be author, title, actor, director. This could be the information in the profile. What can be the text one? So if I want to recommend news, okay. So you saw that news which I got recommended from Google News. So what are the features or the profiles which I should have in the text? Can anyone tell about like? So I put like something called a set of important words in a document. So yeah, so it could be like, yeah, what? City. Yeah, cities and places in the document, and repeating words is a tricky thing, because the most of the time the repeating word is the stop words. Stop words are like are, the, of, in, and. So we'll first remove it probably, and then we'll look for repeating words. So you can make a set of important words. Okay, there are like a lot of heuristic techniques to do that. You give a lot of text, you'll find which are the important words which can differentiate between the documents. You use that and make a list of it as a profile for that document. So in my case, probably one of that important word is Lionel Messi. So I got a Messi news. So that's how it works, right? So this is how item profile works. Another, once you have the profile, you create a vector, as I mentioned earlier. Like try to create a Boolean vector from profile. So can you tell me like how can you make a Boolean profile from a document? Boolean vector from a document. So we understood that we need these profiles, which are like probably important words. We make a set of important words, say the countries, politics, and blah 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 thing, and then we have to make a vector out of it. Okay.
We construct a vocabulary.
Yeah.
And then we have a fixed set of vectors. Whose length is the whose length.
Okay, sorry.
So if the first word is the, so we have one in the place of the.
Yeah, exactly. Yeah, exactly. So I think you understood. So the idea is you take the set of all words in this document. You create a vector, and then whenever a vector of all zeros, go through your document. Whenever the word comes, you put 1 on that dimension. Whenever the word is not there, it will stay 0. So that is like one simple way of doing it, and there are like multiple ways of doing. So that is called one-hot vector. Now the similar way we can have user profiles. So we can look at user and make a profile out of it. So one way is that we don't need to take user information. We can just look at all the items he bought, and we have these vectors for each of the item, and some weighted average of these vectors can be the user's profile. So we are not looking at users information like what the age is, where is he from. That we can do, but to make it simple, what we'll do is whatever items he used or he or she used, we can take the profile of each of them, vectors of it, we'll take an average of it, and it might in one way tell about what he likes, right? So that is user profile. And this variation is something which works well in practice. So probably I don't have much time. I'll skip some details here. Now after user profile and item profile, now is the main task. We have to predict how like will this user like this item or not. So that is the main task, right? We made a user profile. We have item profile. So both of them are vectors in our case. And one simple thing to use is this cosine similarity. This is called. Well, what it means is like you have these vectors. Say X is the vector which shows the user. I1 and I2 are two items. What you and assume that there are only two items in our database now, and then we recommend X the item which is most closer to closer in the angle. So this angle is the minimum. Cosine similarity kind of tells you the cos of this angle, right? The cos theta if this is the theta. So we'll recommend the person the item which is close in this cosine similarity distance. So this is one whole story. How did we start? We started with profiling each item. We got the vector. We took the average of the vectors for the user. We created user vectors, which is this X, and then we find this cosine similarity. And this is like a whole story, right? This is like full story of how to solve the Netflix problem. And this might have solved the problem to an extent, but not as well. So we'll see what are the problems, pros and cons of content-based approach, and then we'll look into why collaborative works in some ways better. So no need for data on other users. So the idea is I only need to know what this user bought. We don't have to know what others did. So the basic idea of collaborative recommender system is that it collaborates from everyone else's profile, what all other people buy, and according to it, it recommends me. But in content based, it only looks at what I bought and the use of the item profile of it. So one thing is you don't need data from other users, and able to recommend users with unique tastes. So that means if I have like a particular news which I am following, say, and there is a keyword which shows that news, and if I'm really interested, and it's not a very popular thing, it will be recommended to me because of this cosine similarity of that particular news, right? So that is one good thing of content based, and able to recommend new and unpopular items because again we have this profile, and able to provide explanation. This is one of the very few things you get in machine learning. Okay, so when you get into AI or machine learning, not many times the system will explain why it did the way it did. For example, you have a face recognition algorithm. You tell like find me a face, it will find a face. Now you ask like why do you think it's a face? It probably won't. It'll throw you a like huge complicated equation with a million parameter and tell that it works, right? But when you use this content based approach, what the system is like, what system can do is it can provide explanation of why this particular item was recommended to you, because it would take all the profile of the new item, compare, tell that you have like these elements of this profile, hence I am recommending you this. So that's a whole story. You know why it works. But in collaborative, that's not the case. Okay, and then there is some cons are basically finding the appropriate feature is hard. So in the case of text and movies, it was fine. But what about images? How can I make a vector of images? How can I find what this profile should be, right? And what about music? And assume that I make one for movies. Now suddenly tomorrow someone comes and tell me like, oh, I want to recommend a system which works for say like audio or music. Can you make it? No, then we'll have to start from the scratch and again do the whole process. But collaborative seems to work without any of these hurdles. And recommendation for new years. Okay, how to build a new user profile. So if there's a new item coming, this will work. But if there is a new user coming, we don't know what he would like because there is no history of what he bought. And over specialization. So that means assume that you can actually try this. Like if you go to YouTube and start watching the same kind of video, then you will only see those kind of videos in the recommendations, right? So this can happen very much in this approach. So assume that I only go online and buy one kind of product, and I would never get recommendation of other things because the profile doesn't match with any other thing. So that is one of the main problems. So unable to exploit quality judgment of other users. That's where the collaborative technique would come. Yeah. Any questions on this? What I have like 7 more minutes, right? Yeah, probably. Yeah. Any questions on content based? Yeah. Yeah. I know you guys are half sleepy, but yeah, I should have bought some music and other things. Should have helped. Yeah, so collaborative filtering. This is the basic idea of collaborative filtering. We have a user X, okay, and then X has some preferences, and we find another n set of people who has very similar preferences with X. So in my case, what would happen is like I watched a couple of Lionel Messi videos, and then there are this bunch of Argentinians who also watch the same video, and they seem to watch this exact same set of videos which I also watched. So the algorithm will figure out that my preferences to this set of people are the same, and then they would recommend the items which these people used. Okay, and then that will be recommended back to me, and then that's how the collaborative filtering works. So the basic idea is find the similarity in users, and what they liked, recommend it back to you. Okay, so that's the basic idea. So let me just give you an example of. Okay, so finding similar users. So assume that the X and Y are two users, and there are 5 movies which has to be rated. It's a very bad way of writing ratings, but yeah, okay, you guys are computer science students, so it's on mine, I suppose. So we have like first movie got star, the second movie got nothing because that guy didn't watch the second movie. Third movie also he didn't watch. The fourth movie he gave 1 star, and the fifth movie he gave 5 stars. Similarly, the Y guy. Okay, now we want to find if these two users are similar or not. Okay, how do we do it? So we can again use cosine similarity, the one which we talked last time. But the problem is, what do we do with these empty slots? One way is put zeros. Okay, but putting zeros is a bad thing, because zero in our convention of putting numbers means that they didn't like the movie at all, because 0 is below 1. 1 is the worst star you can give, and 0 is like worse than that. So you didn't like the movie at all. So that's what cosine similarity gives. So it doesn't work good in practice. What people do is they use something called as Pearson correlation coefficient, which works better. I don't want to go into the equation, I suppose. Yeah, and now assume that we found how to calculate the similarity between two users. Now we could find the ratings. One way would be like we have this person called X, which is our the main character protagonist in this talk, and we have I, which is the item, that's the item protagonist in this talk. Now we need to see like how much the user X will like the item I. You can just take an average of all the people in the X's similarity set. N is the set of all similar people to X, right? And you take the average of how they liked I. This is one way. And other, better way is that you also scale this while finding the average with the similarity. So if there are like two people who are really similar, that his score should affect my prediction score than the people who is like the person who is far away from my from the similarity measure. So many other tricks are possible, which I wouldn't talk. Yeah. So we have looked at user collaborative filtering, where we are looking at similarity in user, but it turns out that in practice, item similarity works better. Okay, the reason being that easier to characterize. So because item details are provided by you, and then one other thing, users have a varied, we have very different interests. For example, I probably would like some Carnatic music at the same time I like hard rock. It can happen, right? But if you take item will be like a mountaineering book, and it's a mountaineering book. There is not much of variance in item. So this can't be captured if you use user collaborative filtering. So that's why it say that item collaborative filtering works well in practice. So I'll do one thing. I'll quickly go through one example of how it would work. Okay, so we'll come back to our good old table, and we have movies on the rows and users on the column. And the yellow ones mean that it's rated, empty ones mean it's not rated. Now we want to see that the fifth guy, would he like the first movie or not? Okay, so what would we do? Like we would, what are the steps of collaborative filtering? So first thing is find the similarity of the first movie with all other movies. Okay, so the way to do it is take all these vectors, like this whole list of numbers, make it a vector, the same here, find Pearson correlation, and you get this list on the right. So this is the highest means, like if you're, yeah, of course this vector is the closest to the vector itself, that's why it's 1. And the second one is 0.41 and 0.59. So these are the two most similar movies to the movie 1. So what do? We have that these movies were rated by the same user 2 and 3, and those are the similarity values. I can use that to predict how much he would rate for that movie. All right. So so here it's actually some weighted average of 2 and 3, and we get 2.6. It's clear, this example. I think like if you don't take anything out of this talk, I would like you to take this part of it. Okay, any questions on this? Yeah, it's already late, sorry. Okay, so again we are using this similarity weighted average to predict. So there's pros and cons. Pros is works for any kind of item. That means if I have an algorithm which works on movies, tomorrow I can just apply the same on YouTube videos, because it doesn't care what the item is. We here in this table, we are not looking at what is behind this, who is this user. We don't care. We only have the information of what he rated on these movies, and we have the same with movies. We don't have any extra information we are using. So this technique can work for any kind of item, and it has this problem of cold start. Means if there is a new item, that column is empty, and if there's a new row, like new user, that also is empty. So that is one problem. Cold start. Sparsity is, if the matrix is too sparse, the cosine similarity values wouldn't make much sense. If the whole matrix is all of zeros, the similarity measures won't make sense. And yeah, the same with first rated. And as he mentioned, the way to do it in practice is use something called as hybrid methods. Use content based as well as collaborative based to solve the problem. So one idea is use content based to make a prediction. Use collaborative based to make a prediction. Take an average. Okay. So collaborative says 3, content based says 2.5. You take 2.75. Okay, that is one way. There are more sophisticated ways of you doing it, which will need a graduate course in math or computer science. So I'll probably I think I'm overshooting on the time. Probably I'll skip the last part, or I'll just show one last technique of what latent factor models mean. Okay, so the idea is, can we use the matrix we saw and make a vector representation for each of the movies? These are the movies. Like you can see the Princess Diaries, the Lion King, the Independence Day, and the same dimension representation for the user. These are the users. Okay. Can you do some technique to get a representation this way, where a dot product of this vector times this vector will tell how much rating they have? So that is a technique that's the big idea in latent factor model. So and each of the dimensions can mean something. So geared towards male, geared towards like serious funny, and left towards female. I mean, yeah, probably more, you may not agree with me on this. And the way I put, so the parts where you have to focus more are on. Let me just skip the part where you have to focus more is like, say if I want to figure out what this guy likes. If there is a movie which is closer to him, Dumb and Dumber, he might like it, but he may not like the color purple. Okay, but there are some people like who are like, yeah, this guy, for example, the doctor, yeah, he seems like a doctor. If the guy who is near there, right, he doesn't seem to have a particular interest, at least in the dimensions which we have mentioned. So that means that we have missed out something in this representation. We are not able to show this person completely on this scale of vectors. Okay, so so to achieve it, the idea is you have a vector, you have a matrix, you write it as a multiplication of two smaller matrices. Okay, so so assume that this okay this row I can actually see it here these letters but not on the screen. So these are items and these are users, and it's written as multiplication of two vectors, the two matrices. So this is item matrix and that is user matrix, and the 3-dimension kind of shows a vector representation for the item and the same for user. So the question is, how can we find these matrices? And there are like a huge bunch of algorithms to do, and there is theoretical proof of will that algorithm converge or not. Yeah, I think that's kind of what I'll explain. So if you have any questions, you can ask. No, if you are not using the content or the information about what item is. Yes, we can, but when we are looking at collaborative filtering, we don't take any of the information we have the item. So in a collaborative setting, if we have a new item, we won't be able to solve it properly. But in content based, yes. So the idea is in practice, if there is a new item coming, you use content based technique. But if you have enough rating of that item, we try to focus more on the collaborative. Yeah, any other question? Probably it's too late. Yeah. Yeah.
Utility function of all of us for this talk equals time. Thank you, Saneem.
Yeah, thanks a lot. Can you take?
Yeah.
So no, most of you will be what, third year BTech, is it, or are there second year BTechs as well, or? Okay, second year. Oh, nice. Yeah, so one thing you can, at least for the third year BTech, the vacation is almost over, I suppose. So for the second year BTech, what I would say is, you can apply for internship next year in IBM Research if you are interested. Come on, I have to do this, right? Work for them, so yeah. So and also you can apply for UGC internships in IISc, right? So there is. Oh, okay. It used to be Union Grant Commission internships. So there is Narendra Modi internships which you can apply for, and then you can also So if you want to work on this set of topics, the best way is to take a problem and solve it. What I mean by that is you can read textbooks, of course, but the problem is with textbooks and this content is this huge area to cover. Okay, so what you would waste time is you will do BFS and not DFS. So that's what we all do. So we'll go like breadth-wise, read topic A, B, C, and not understanding any of them. So one way to do it is you take a problem, try to crack it, you go in depth on that, and that's how you develop. So one way is check on Kaggle competitions on similar problem and see what you can do if you are interested in this area. Okay, thanks.